Alright guys, this is Matt with Thrive Off Grid and Thrive Energy Systems. Alright, so finally we're making some progress on the VersiFire development. This week I've got it about 95% complete and mechanical. So the next stage is to start working on the electrical systems. And then we'll get it wired up, get the hardware created. And then once there, we can start programming it. Alright, so yes, this will be automated. Basically, this consists of a downdraft gasifier. It's optimized to produce charcoal. And this will be, the intent of this design is to have a wood gasifier that works in conjunction with the DFX series charcoal gasifiers. Alright, now when you're producing charcoal, rather than waste the energy to produce the charcoal, we're going to use that energy in the form of the wood gas, the pyrolysis gas produced from this process. So basically you're going to have the best of both worlds, because you're going to process fuel like you would for any other normal wood gasifier. But then you'll have the luxury of running an engine on charcoal, which is far more viable. It's you're not going to produce tar. It's going to run stable. You're not going to need automation to keep the engine running. They're much simpler. They're much less complex. I mean, that is the gasifier right there. I mean, that right there runs an engine along with an engine attachment kit and a simple fine filter. But for the most part, that's it. Alright, so now what you're going to do with this machine is this machine will produce gas to supply the house. And the intent is to run basically any gas appliance that would run on LP or natural gas. We want to be able to run those appliances on this gas instead. I won't know how viable that is until we get there, but if anything, this should be able to supply gas for heat. And how you'll do that is you'll convert a wood stove basically to run on this gas. This here is just a barbecue grill burner, and we're just gonna modify a stove and put that in there and run the gas produced from this guy in there. So this will be basically a combined heat and power system when you couple this with the DFX. So you're going to have two energy supplies. Alright, so right here is the gasifier reactor. This is your gas out. This is the gas exit exhaust that goes into a coarse filter. This will be like filled with hay or chips, something more coarse. This one here will basically cool the gas. Well, actually both of them will. And then there's a crossover pipe down below here, and that goes underneath and around to this side. So the gas comes in through the bottom, and this one will be filled with sawdust or something more fine. Probably chainsaw dust would work best for that. And then here's your startup blower. That will supply gas from the gasifier to some plumbing arrangements here. The gas will come up through here. This valve will open, and then there's some other valves down below, and I'll show you that in a minute, because I'm going to show you how to remove the charcoal catch bin here in a minute. But we'll go over this real quick. This is this valve will come open, the blower will come on, this machine will self-ignite. And we'll probably use the gas from the system. There's going to be two systems, a glow plug arrangement, which is in the back here, and then this here is actually where the jet is for the gasifier. We're going to supply gas and air along with our ignition system to use the gas to basically light itself. Okay, so while that's happening, the blower's on, this valve's open, the gas is flowing up through the flare cup. This is a GM LS ignition coil, and you got your 12 volt positive. This is a shared 5 volt 12 volt ground, these two, and then this is the signal wire. You just supply this with 5 volts, and this will trigger this, and this will fire the spark plug up here. And then we got a thermocouple. This will tell our controls that we have a lit flare once that gets warmed up from this being lit. Alright, so once it sees the flare's been sustained for a few, I think it's 10 seconds, then it will go into charge mode. And then, so we have some valves down here which direct gas to one or both of the accumulators. Alright, so I don't know if we can see down here or not. The dog. Seiji. The dog's giving me some lovin's while I'm trying to show you guys that. But anyway, those will direct gas to the accumulators, and then there'll be a proc switch actually mounted in here that I don't have installed yet. But there'll be targets on these barrels and these inner drums. So as they lift up, once the lower target is tripped, that'll send a signal to the controller saying, hey, we're full, shut it down, and it'll shut everything down. And then this one will go into a cooling cycle. Now this one will already be full, and this one will have completed its cooling cycle, and this will be the supply. So while this one's cooling, this one will be supplied, and then as that goes down and trips the switch, then it starts the whole process over, and it basically switches accumulators. So you're just going back and forth. Alright, so this is going to be a low volume machine. So this isn't going to work the same as an engine grade gasifier. So what's gonna happen is this is gonna cycle on. It'll charge the barrel, and it'll probably take about the whole process will take about 3 minutes. And then while them barrels are while the gas is being consumed via the appliance, you know, this is cooling down, and it's converting your fuel. It's drying and converting the fuel to charcoal. So it has a lot longer dwell time to be processed into engine grade charcoal, plus producing a clean gas for this system, direct from the raw wood. An engine system, this is going really fast. I mean, like if you were to power a truck with this thing, you'd be lucky to get, I don't know, maybe 40-50 miles. You know, this is designed to run a house 24 hours a day on a single hopper load. At least that's the intent. I won't know until we actually build it and try it. But I'm anticipating this should be able to, if you were to run just a heater, possibly a hot water heater, maybe evaporative type fridge that would use gas instead of electric. This should be able to supply all those gas needs 24 hours a day for, say, a small cabin, 1-bedroom cabin, or RV, 1-bedroom house. Nothing too crazy. If you get any bigger than that, you might need 2 of these, and there's nothing stopping you from running 2 of these in tandem. And this is going to be pretty low cost, because we're not going to supply any of these barrels. You're going to supply those, and you're going to modify and build this. All we're going to produce is the reactor, the frame system, all the plumbing parts, everything you need to build this, but we're not going to supply the barrels. You're going to have to buy them, source them, and modify them. And there is going to be an option, the 2 filter barrels, there's going to be an ammo box option where you could use ammo boxes, just like the barrels there, but you'll be using the ammo boxes. That might make it a little lighter, maybe easier, don't know. But this is what we had laying around, so that's what I used. So it'll just make it more adaptable and give you some options anyway. Alright, so I'm going to set you down. I'm going to show you how to remove the catch bin. Now this barrel is actually suspended. So when you get water, yeah, it's something I didn't explain here. These accumulators, how this works is there's a telescoping tube in the center. And it's square tubing, so these can only go so far, right? So we have to keep them what's the word I'm looking for? The radial movement has to be static in order for our targets to work, because the target can't, you know, this can't spin around and the target will end up over here, or sensors, you know, over here. So we're using square tubing and it telescopes. Okay, so the gas in and out goes through that telescoping tube, and then around this will be water. So you're going to fill these drums all the way up with water, and that creates the seal for this. And just the sheer weight of this is what's going to supply the gas pressure. In fact, we'll be able to put weights on this if we need to add more line pressure. But again, you know, it's one of those things I got to build it and see. You know, math is great, but generally it doesn't. You know, there's a lot of variables involved. It's hard to get all those variables factored into your equation, and you know, it's hard to be accurate. So yeah, just real life trial and error is the way to do it. Okay, so anyway, yeah, when you have water filled into that, that's going to support this much better. Right now, oh yeah, but on the back we have these here, and these those kind of lock on the bottom rims. So once these are full, the barrels will put weight on those, and then that'll support this whole thing. Alright, so now I'm going to show you how to remove that. It's fairly simple. Yeah, you should be able to see. Alright, so right here we have a foot pedal that pushes a lever up to support this. So I can basically undo this. And I can pull it down and basically remove that. You'll probably want to have another one of these to replace it, or you could dump this into a 55-gallon steel drum with a lid, but it may be a bit hot from being, you know, under the use. So I would just put a lid on it and then have your second one empty, and then by the time that needs to be filled again, it'll be cool. Alright, so yeah, when you have your replacement, and that's it. Alright, so anytime that you fill that hopper, you need to remove that hopper, or the catch bin. So that's pretty much how the intent of this. For every 50 gallons of fuel, it's going to make 20 gallons of charcoal. And then whatever you didn't make in charcoal, you made in processed gas to fuel your gas applications for the house. And what's nice about that is this energy conversion is direct, versus running this gas wire to run an engine to convert to electric. You're going to lose 75%, you're going to have a 75% loss in engine losses. So this is a better system. This is the future standalone home power generation using gasification. So this is, this is the next generation. Alright, so yeah, another news, we're still going like mad. We got 6 shipments here. Now we got another round of 6 getting ready to be assembled. Chris has started this week on this one. We're hoping that all 6 of these will be done by the end of the week, and then we'll start shipping them out. And then we start the next cycle. So yeah, I've officially retired from manufacturing January, just so that I can start working on development. That's basically going to be my job as shop manager and then development. We have some other things besides the VersiFire. Next generation controls. This is the control box for the VersiFire, so this will actually get mounted up here like so. And this hardware is going to be a standard hardware system. So when I start working on the Worx version of this for the DFX series, this hardware package is going to also be available for that. It's just how it's going to be coded and how the wiring will be routed out of it that may differ. But other than that, the hardware inside will be standardized. So this is what I was going to use before, but it's just too small. I still need to get a power supply in here to run 5 volts. And then also we need a buck converter to run the Amatec blower on 48 volts DC. So, and we are going to run that on both AC and DC. So when this is in startup mode, it'll be running on DC. It runs much slower. And then when it switches into charge mode, it'll go full blown AC power, and those things will fill up like in a heartbeat. And that thing will have plenty of power. They use these things. They use these blowers for lifting big boats like yachts. They have these big mattresses that they use these things to fill up, and they can literally lift up a huge boat. So yeah, it should be no problem for that thing to fill those accumulators. So yeah, anyways, I'll be working on this tomorrow. This is going to be the box we're going to use. We're going to cram all this thing in here. So yeah, we've been doing controls since 2013. So yeah, we've learned a lot in almost 10 years. Yeah, it's 2023. It's 10 years. Wow, I can't believe it's been that long. So yeah, the Arduino stuff that's on the market, stuff's junk. That stuff will just burn up. And then yeah, those relay boards, yeah, they're absolute nightmare for a client to replace, because you can't just remove usually what happens is the relay will go bad, and then if that goes bad, the whole board's junk, unless you can unsolder it and solder in a new one. And regardless, you still have to remove the board. And if you got it all hardwired in, good luck with a customer wiring that puppy in. It doesn't work. Trust me, I've been there, done all that. So I use automotive stuff, 30 amp relays with built-in circuit protection, and we have a new MOSFET board. So they're MOSFET controlled to convert from logic to this. There's other options on the market, but they're too big. We got to keep this compact. Besides that, wiring this stuff up costs a lot of money. To hire an electrician, they want $30-35 an hour. I can't afford to pay pay 20 hours to build one of these boards. I mean, you add that up. That's what's gonna. I gotta factor that into the cost. People aren't gonna buy it. It puts it out of market reach. So you got to keep things small, compact, and as low cost as you can, but yet it's still got to work. So yeah, that'd be Yeah, there's more I can say, but I'm not gonna. Alright, so anyways, that's where we're at. The Worx version of the controls that will be coming this spring. So we're gonna offer two control packages, a light version and then a full self-run system with autonomous capability, and that will have a cell phone app. In fact, that cell phone app is going to work with both systems, the VersiFire and the DFX3 Worx package. So you'll be able to control both of them. Both of them will send alerts. They'll let you know, the status of things, status of your battery bank, because there's going to be a control module for that. Basically, that's going to hook into your batteries, and then our controller is you're gonna program your high and low voltage parameters, and basically once your low voltage parameter is triggered, our controller will go into action. Will self-fire the gasifier up, and basically the same process for the VersiFire will apply to this. This thing will go through its ignition, self-ignition startup procedure, and then once it gets there, then where this will differ is this will fire up the generator, and then the generator will run through the hopper, and that'll have an AFR mixer control, which we've had developed since 2014. Hey, you be quiet. So this will be really, and it's a charcoal unit too, so it hardly even needs the AFR mixer controller. But yeah, so it'll run through the hopper, or it'll actually be on a time deal, or if you do manage to trigger your high voltage on the battery bank, then it'll go into shut off mode and it'll shut down automatically. And then same thing with the VersiFire. It'll tell you, if it misfired, if it didn't,